Hey guys, welcome back to another Maps Challenge question. Let's have a read of this one together. So the diagram shows two right-angled triangles inside a square. The perpendicular edges of the larger triangle have lengths 15 and 20. What is the area of the shaded quadrilateral here? Okay, cool. Have a pause of the video, have a go at yourself, and then unpause, and we'll have a go at it together. Cool. So how am I going to find this shaded area? Well, it's not a nice looking quadrilateral. It's not regular, so it's a bit hard to find the area of that. If we were to find the areas of the triangles and sum them together, then we could subtract that from the area of the square, and that would get us the shaded region. That's more useful because finding the area of a triangle is quite easy. It's half base times height. Cool. We've got the base and height for one of the triangles, but not for this one. If we were to find the base and height for this triangle, then the question would be quite easy. So that is our initial plan. So let's draw this out. Now, I think there's going to be some sort of trick in this question, and we'll see why. What happens if I label this angle as theta? Well, since it's a square, this angle here must be 90 minus theta. Okay, what would this angle be? It would be 90 minus theta, since angles in a triangle sum to 180, and this angle here is 90. What about this angle here? Well, if this is 90, and this is 90 minus theta, if we add those, we get 180 minus theta. And angles in a triangle sum to 180, so this must be theta. Cool. So what we can see here is that these two triangles are similar triangles because all of the angles are the same. Cool. What do we know about similar triangles? We know that the ratios of their lengths will be the same. So for example, the ratio between the hypotenuse will be the same as the ratio of this length and this length. That's very interesting. Now the good thing is we know the hypotenuse of this triangle, since it's one of the sides of the square. It's just going to be 20. So let's just put that in straight away. Cool. What I want to do is find the hypotenuse of this triangle, because then we can use it in our ratios. Okay, so let's do the square root of 20 squared plus 15 squared. That gets me the square root of 400 plus 225, which equals the square root of 625, and that is just 25. Very nice. Let me draw out these triangles just to show it a bit more clearly what's going on. So the lengths on this triangle are 20, 15, and 25. The lengths on this triangle on the left are 20, and we don't know A, and we don't know B. Okay, let's find A and B. So using the ratios, we know that 20 over 25 is going to be equivalent to A over 20, right? The ratio of the hypotenuse for the triangles will be the same as the ratio for the length next to theta. So that's going to be A over 20. So now we just need to rearrange and get A by itself. So A equals 400 over 25, which equals 16. So cool, we found that A equals 16. Now I just need to find B. So using the ratios, that's quite easy. We can see that for this triangle here, this length is 3/4 of this length. Therefore, the length B will be 3/4 of A, which is 16. So 16 times by 3/4, that's going to be 12. So B equals 12. Cool. This is very good now because we've got the height and the base of each of the triangles. Therefore, we can find the areas of the triangles. So let's rub some of this out so far. and find the areas of the triangles. So we've got a half, 16 times 12, and we've got a half, 15 times by 20. Okay, let's work that out. We've got 8 times 12, that is 96, plus 10 times 15, 150. That equals 246. What is the area of the big square? Well, each side is 20, so the area of the square is 20 squared, which is 400. Okay, so to find the shaded region, we just need to do the area of the square minus the sum of the areas of the triangles. So we have 400 minus 246, and that gets me 154. And that is the area of our shaded region, and it's one of the answers D. So we're done with the question. Cool. If you guys enjoyed the video, then check out some of the other ones, and I'll see you in the next one. Bye bye.